Or Tom. Sorry, they're at Tom. All right, so real quick, we already did these two, but let's just point them out. So, of course, as we approach this graph from both the left and right at 2, we get to 3. And as we approach 1, the asymptote, on the left side we get negative infinity. On the right side we get positive infinity. Therefore, it is undefined because the left side does not equal the right side. Now let's jump in and do some new stuff, which is really just extensions of what we've already done. All right. Consider the function over here, which is an absolute value function. That's why it looks like a V. Graph of f of x is pictured there. From the graph, determine the following limits. So the limit as x approaches 0 of f of x. Okay? If we use the equation. So if I just literally plug in 0 into this equation here, I'm going to get the absolute value of 4. Great. Times a half. 2. 2 minus 4. Minus 2, right? You can see what I'm getting at? I'm just literally plugging it up here. I'm not going to write that all out, right? If you guys are in this class, you should be good enough to be able to figure that out from that simple equation. All right. Now what about from the graph if I take the limit? So as I approach 0 from both the left and right, look at that. I get negative 2. Amazing. What about if I approach 2 only from the right-hand side? Okay, what do you want to do the graph first this time? So only from the right-hand side, we get to what? Negative 4. Let's plug it in here, make sure that's still true. So if I plug in here 2, that means I get negative 4 plus 4, which is 0. Absolute value of 0 is 0. Times a half is 0. Minus 4. Hey, look, it's minus 4. Amazing. What about 10? Let's plug 10 in. What's 2 times, or negative 2 times 10? Negative 20 plus 4. Negative 16. Absolute valued? 16. Times a half? Minus 4? 4. Let's see if we get the same thing on the graph. So, oh, I can't. We'll assume that it's 4. Why am I going to assume that it's 4? Because the other 2 times when we plugged it in, that's exactly what it is. And if you remember, I've even said that in class. I've kind of hinted at this fact that the first thing you should do is just plug it in. Because sometimes you don't even need a limit to be able to figure out what the limit is, right? Because if the graph exists and it's continuous, you did a question like this in your homework, then that just means that you plug it in and that's the value of the limit as well, okay? All right. Feeling good about that? Great. When the function is defined and it's continuous at x equals a, then the limit as x approaches a of f of x can be found analytically, because really what this means is simply find f of a. That's all it means. Okay? Just find f of a. As long as the key there, guys, is that it exists or it's defined and it's continuous, which is kind of dumb, because if it's continuous, that means it has to be defined, right? Otherwise, there's a hole and it's not continuous. So really the key here is like, is it continuous? And you have to do a question like that in your homework. Do you guys remember which one I'm talking about? You had to find it from negative 1 to 1 and just tell me if it was defined for all values of A or C. I think it was C. Oh, you guys didn't do that one? No, it wasn't true. I think it was like question 9. Look at that. Done it so much I think I know the exact question. And it asked you about a graph. The graph kind of looked like this. This was negative 1. This was 1. Then it had some kind of jump, right? And a whole bunch of you were like, oh, I'm not sure because of this. Well, that's the boundary, so it doesn't matter. From negative 1 to 1, it was continuous, and therefore all the limits there existed. All right. Let's actually apply this here now. Now, I don't have a graph. Remember I told you I'd take away graphs? If I don't have the graph, what's the very first thing that I should try to do? Plug it in. Is that what you're going to do, or are you going to tell me the answer?
So we just plug in 3 into x.
Good. So we're literally going to do that. Then I'm going to work that out. Are you guys good enough that we can do this in our head and go straight to an answer? 3, man. X is approaching 3. We lost Pablo. It's okay. He's back. All right. So 3 squared is 9 times a half is 4.5 minus 6, negative 1.5 plus 3, 1.5 or 3 halves. Okay. So that's the limit. Because it exists. It's continuous. How do I know it's continuous? It's a polynomial. Polynomials are continuous. I mean, I guess so. All right, so here what are we going to do? We're going to plug it in. Before I plug it in, what should I check? The 3's not a problem. Where is there a problem on this graph? What will make this rational expression not continuous? When what? What has to happen?
When there's a bottom equals 0.
An asymptotal variable, how do I find that?
When the denominator is 0.
When the denominator is 0. So in this particular case, this part of it cannot equal 0, which is fine because for us, that's not going to happen at 3, right? That's going to happen at 3/2. So we're fine, right? Do you guys see how it happens at 3/2? Good. So that means that I can go ahead and I can just plug this in. So I'm going to get, what, 15 plus 2, 17 over 6 minus 3, 3. There's my answer. Amazing, right? Do you see why it was important to first check, though, that I'm not going to get something weird? If I forgot to check, what would happen here? It would just be over 0. And then I would know, oh, I can't do that. I need to do something else, right? I can't just plug it in. All right, so the next one's this one. I'm going to plug this in. I'm going to go 2 from the left. Does the left matter yet? No, not yet. First thing I'm going to do is just plug it in and see if it works. Where does this thing not going to be okay? At what? X equals what? Where does it have a problem? Somebody said it. -1. I heard somebody, a couple people say that. Yeah. So I'm going to plug it in. That's going to be the square root of 2 plus 2, which is square root of 4, which is 2 minus 1 over 2 plus 1, which means I'm going to get 1/3. You feeling good? Let's see if you still feel good when we do some trig. All right, so this one, I'm just going to plug this in. Is there any way to make sine not defined? It's defined everywhere, right? There's no value that I can't use. So, okay, so that means that I can go ahead and just plug this in. So I'm going to get the sine. I'll write it this way for you. 2 pi over 2, which is really just the sine of pi. What's the sine of pi, guys?
Minus c. 0 plus 0.
0. My answer is just 0. Right? Sine of pi is 0. That's at 180 degrees, which is right on the x-axis. And what is y at the x-axis? 0. Somebody forgot to do the phone. That's okay. All right, this one, it's a little bit tricky. What's the only value now that's going to make this one not work? Theta equals what? Guys, if it's your phone, just go turn it off, okay?
0.
Huh? 0. So as long as it's not 0, which it's not, we're doing 2 pi over 3. We're going to get cosine of 2 pi over 3. How good are you guys at this? Times 3 over 2 pi. Why is it times 3 over 2 pi? How do you divide fractions? Keep, change, flip. Right? So I keep the first one, I change the division to multiplication, and I flip the bottom fraction, right? Keep, change, flip. Or whatever you guys do. I don't know, you guys do like ear or something? I don't know. That's what they're always telling me. They're always drawing ears on their page. Anyway, so we do this. Cosine of 2 pi over 3. It's over there. 2 pi over 3, we're in the second quadrant, so it's definitely negative.
Negative square root of 2 over 2.
Negative square root 2 over 2? No, that should be 3 pi over 4. Square root 3 over 2? Now you guys are making me second guess it. Yeah, -1/2. Okay. You guys made me second guess it there for a second. All right, -1/2 times 3 over 2 pi, which is just -3 over 4 pi. It's ugly. Does it matter? No. In my class, guys, leave your answers in terms of pi. Unless I tell you to like round your answer, just always assume that I want it in terms of pi. Don't give me like -3 over 12 point blah, blah, blah. Don't do that, okay? Don't do it. All right. Next one, same thing. I'm just going to plug it in. So I'm going to get log base 8 of 2, right? 11 minus 9. Anybody know what that is? How good are you guys at logs? Yeah, somebody's got it. Anyone else? 2 people got it. If you're not sure why it's that, what this means is the base of 8 to the power of something equals, wait.
2 to the power of something.
Thank you. I was like, that's not right at all. I wrote that wrong. 2 to the power of something equals 8. Yeah, either way, yeah. That's not right, guys. No, that's not right at all. It's not 3. No, no, no. You guys messed me up. It's definitely a third because the base has to stay the base. It's 8 to the power of something equals 2, which is why it's a third. Yeah. Sorry. Yeah, it should be a third. If you can't see that it's a third directly from this, you could always solve it algebraically. Go 2 to the power of 3x equals 2. And then what you do is you drop the base. 3x equals 1. And then x just equals 1/3. Okay? You guys almost caught me there. I was like, no, the base is 8, so it should be 8.
And maybe how did you do it algebraically?
This part algebraically? So another way to write 8 is to write it as 2 to the power of 3, right? The reason I'm doing that is I want these bases the same, because if the base is the same, I can drop the base and just compare the exponents. So I get 3x is equal to 1, and then I can solve to be x is 1/3. Okay, if I can't just look at it and see that it's a third. Make sense, Pablo?
Yes,
Perfect, no worries, man. All right, let's analytically find these ones. So, first thing I'm going to do is just plug it in. Plug this in, I'm going to get 9 minus 12 plus 3, 0. Not necessarily, we'll find out. 9 minus 6 minus 3, 0. Uh-oh. That doesn't work. Let's see, we'll do this one. Plug in 1. I'm going to get 1 plus 4 plus 3 is 8. 1 plus 2 is 3 minus 3, 0. Uh-oh. I'm going to plug in 1 again, but this time from the positive. It's the exact same thing. I'm going to get 8 and 0 because I'm still just plugging in 1. So what's the problem here? Yeah, so basically if we try to evaluate these limits by direct substitution method, those using the previous example, basically they're undefined. Yep. So before we go ahead and factor them, let's take a look at the graph so we can make sense of it. But you are correct, yes, we can try factoring them. That won't always work, but often it will. Well, let's go ahead and actually try and plug it in here first. So just because it's undefined, remember that doesn't mean that the limit can't be reached. That's actually the whole reason we have limits, right, is to find what the thing is approaching when it's undefined. Okay, so consider that function above, this guy here that we already did. And from the graph of the function pictured to the right, what is the value of each limit? So as we approach -3, we can see here that the coordinates of the whole are at 1/2, so this should be 1/2. Correct? Guys all with me on that one? Perfect. Now, what about if we approach 1 from the left-hand side? We're going to drop down here to -infinity. And when we approach it from the right-hand side of 1, we're going to fly up to +infinity. Yes, Daniel?
Wouldn't it be undefined because it doesn't?
That would be the limit at 1. Because these are one-sided limits, they exist. Because we're just looking at one side. But yes, you're correct otherwise. If I tried to find the limit as x approaches 1 proper, it wouldn't exist. That's correct. All right, task now is to determine how to find these limits analytically. I think it was Pertuz that already told us. What did you say? See, I listen to you and pay attention, just not the first couple minutes of class. All right, so let's go ahead and let's take a look at that. Let's factor this thing. I'm looking for something that multiplies to 3 and adds to 4. I mean, that's just x plus 3, x plus 1. And on the bottom, I want to multiply to -3 and add to 2. That's going to be x plus 3 and x minus 1. And technically speaking, we should write out that this is still the limit happening, right? Now, of course, we like that because we can see that those x plus 3's cancel, which means I'm really doing the limit as x approaches -3 of x plus 1 over x minus 1. Now I can plug it in. -3 plus 1 is going to be -2. Negative 3 minus 1 is negative 4. The negatives cancel. And I get a half, which is exactly what we got in the picture, right? So that's good. If we got something different, we should be worried. Is that clear to everybody? You look kind of scared. We're good. We're good. All right. Now, what do you think would happen if I did the other one? I just plug in 1, and when I plug in 1, what's going to happen? If I plug in 1 to this like reduced form here, because remember the other limit we did was x approaching 1. It's going to be undefined, right? It's going to be divided by 0. And then we have to do something further, which we'll talk about in a later lesson. All right, we got to like do some more analysis then at that point. But we're trying to solve them in like the easiest way. Actually, I think I do it here. No, I do it right here. Never mind. It's in this lesson. I lied. All right, based on pre-calc, rational functions non-removable infinite discontinuity, graphically a asymptote exists. Since the y values do not approach one specific value from both sides at a asymptote. Wow, I just left out the p altogether there. And the limit does not exist. If they do approach the same thing, the limit does exist, right? It's just in our particular case, they're approaching two different things, so they wouldn't exist. All right, we can determine if the one-sided limits are negative infinity or infinity. Okay, and that's what we're going to do here, and we're going to do it with a little bit of, I don't know, analytics, let's say. A little bit of analytics. So what I'm going to do is I'm going to take this, and really I'm going to go to the simplified form, because we already did simplify it, so let's do that, although it'll be the same no matter which way we do it. I want a value that's a little bit to the left of 1, to find the left-hand limit, right? Like this would be the left limit. Oh, right. It's actually written right there. You can see that it's the left limit. So I want something a little bit smaller, 0.9. Is that a little bit to the left? Do you agree it's a little smaller than 1? Perfect. So I'm going to plug in 0.9, but I don't care what the value is. I'm not going to say, oh, it's like 1.9 over negative 0.1. That's not what I care about. Because I know it's going to infinity or negative infinity. All I care about is the sign, right? The sign is what's important here. So if I plug that in on the top, am I getting a positive or negative number? If I plug it in the bottom, positive or negative? Negative, right? 0.9 minus 1 would be negative. What's positive divided by negative? Negative. Therefore, negative infinity. You see how that works? I don't care what the number is. I just need to know the sign because I know it's going to an infinity. Okay? Same thing here, a little bit to the right. 1.1 makes sense to me. 1.1 plus 1, positive. 1.1 minus 1, still positive. What's a positive divided by positive? So it goes to positive infinity. Cool, right? We get to use analytics because we're smart. I don't know if I should be worried that some of you laughed at that or... All right. So, are we okay? Can I keep going? Does that make sense? Awesome. So now we got the graph of this new function g of x, which is the square root minus 2 over x minus 3. Pictured over here to the right. Often rationalization can be used to evaluate a limit analytically. Now, we're going to like engage our pre-calc a whole bunch here. If you don't remember how to do this super well, it's not the end of the world, but it does come up every once in a while on the AP exam. So it is a good thing to remember, but it's usually like 1 or 2 exams, or 1 or 2 questions at most. Okay? I'm not answering that question. First of all, which test? Second of all, you can look it up. Same as I will have to. All right. So, oh, sorry, don't put an equal sign. Let's put a multiplication. So we had this problem when we had something like this and we couldn't figure it out because right now if I plug in 3, I'm going to get a 0 on the bottom. It doesn't work. So what I could do is I could rationalize. Now, normally you did this to rationalize the denominator, but we can rationalize anything. So let's go ahead and we're going to multiply by the conjugate. Anyone remember what that is?
What?
Conjugate. No? We're going to take that square root, and instead of being minus 2, we're going to go plus 2. How come? Does anybody remember why we do that? We flip the sign because what it does, what is this top now? What is the numerator? Yes, but why? Let's get to why this is happening. Like what am I doing when I multiply those two things? It's a special kind of factor, or like not factoring, but special kind of binomial. It's a difference of squares, right? Like if you look at it, the first thing is going to be squared. The last term is going to be squared. One's positive, one's negative. What happens to the middle term on a difference of squares? That's why we like difference of squares, guys. Yes, the middle term goes away. And if the middle term goes away, what else goes away in this particular case? The root. The square root's going to go away on the top, right? So that's why I said normally we do this to rationalize the denominator, but we can use it at any point. It's still fine, because effectively what did we do here? We multiplied by a really fancy form of 1. That's all I did, right? I mean, it's a fancy 1, but that's a 1. Would you all agree that this is 1? Yeah? So that's all we're doing. All right, so let's work that out. We'll write limit again, because it is still the limit. When I multiply these top two things, the square root just goes away, because square root of x plus 1 times the square root of x plus 1, it's just x plus 1. And then the middle term we know is going away, so I don't care. But I do care that it's negative 2 times 2, which is going to be minus 4. On the bottom here, I'm just going to leave them that way. So x minus 3 and the square root of x plus 1 plus 2. Now, why am I leaving them that way? Because the whole reason I'm doing this is to hope that that x minus 3 goes away. If it doesn't go away, this isn't going to work anyway. So that's why I want to leave it as a factored form. Does that make sense? Right? Because this x minus 3 is the problem. So if it doesn't go away, I should just stop what I'm doing anyway and move on to another method of solving. Okay? Now, in this particular case, it will work, because what does that numerator become? Right? Yep. No, watch. This is going to be x minus 3 over x minus 3 square root of x plus 1 plus 2. What happens? Right? Which means that it's still like a non-permissible value. But remember, we're talking about limits. We don't care if the function's defined. So even though you're correct, there's still going to be a point of discontinuity. It doesn't matter because we can find the limit. Does that make sense now?
Yes.
Yeah? Perfect. Awesome. So then we're going to go ahead and do that. Okay? And so now, remember, my first step, and every time I simplify it, is always to go back to that first step. Just plug it in. Just see if it works. So I'm going to plug in 3. And I'm going to get the square root of 4, which is 2, plus 2, 1/4. So this whole right here has to live at 3, 1/4. Right? I know that that's where that thing lives now because I just figured out the limit. How are we feeling about that? Good? Yeah, Jack?
So, like, you remove both x minus 3 and what's it? What put the numerator? Like, what you...
Oh, the numerator, if everything's gone, it's just a 1, the placeholder, right? Yeah. And then the bottom, I know I did it in my head, but I think you guys can go 3 plus 1 is 4, square root is 2 plus 2. All right. Should we do the next one? How are we feeling? Not so good? Okay. So we've got a piecewise function over here. We do a lot of this with piecewise functions because, of course, that's where we get weird things happening is in piecewise functions, piecewise or rational. So what we're going to do is we're going to find the equation of each of these. Don't panic. You know how to do this pretty easily, right? It's just a line, so it's rise over run to find my slope, which is -1. And then I need to figure out where it's going to contact the y-axis. I could either just extend it, or I could algebraically find it. I think it's easier to extend it, -5. Okay? What's the constraint? In this particular case, x needs to be less than -3. Okay?
Okay.
Now, let's find the other one, because I think you guys are better at lines here. This one's going to be -1/2. And if I extended that one, I'm going to hit it at -1. My constraint for that one is that x needs to be bigger than 2. All right, this one in the middle. Anybody remember how we find that? We're going to use vertex form. What's the vertex down here? -1, -6, right? Good. So what that means is that we write it as x minus the x coordinate, so x plus 1, all squared, minus 6. You guys remember writing them that way? You had to complete the square to do it? Okay. I don't have time to go over that right now, but we'll go over it later. I just did it with my BC students. I'll maybe post the same thing for you guys. And what's the constraint here? You guys can at least tell me that part.
X is greater than -3 and less than
Close? Less than or equal to 2.
greater than -3.
Right? It's got to be less than or equal to because there's a filled in dot. That's the only thing you messed up there. Does that make sense? Yeah? Good. Perfect. Look at how good we are. All right. Use the equation that you wrote to find the following limits. Confirm it based on the graph. And if it doesn't exist, state why. What's our reason why? Left side does not equal right side. That's our reason, right? Always. All right, we're going to find the limit of f of x as x approaches 2 from the right. If I'm approaching 2, which are these two equations, from the right, meaning it's bigger than 2, which of these two functions do I need to use? The bottom one. So if I plug that in there, I'm going to get -1/2 times 2 minus 1, which is, well, this is -1 minus 1. It's -2.
Mr. White, you plug in the, why did you plug in the 2 in the equation? We could just look at the graph. Right?
Because the whole point is I'm getting you to the point where we don't need graphs, right? That's why we've had questions where we don't have graphs. And this says confirm it based on the graph. You're correct.
Okay.
But it's because the whole point is I'm trying to get you to not need it. The graph right there, right now, is a crutch. Later, you won't get it. Okay? All right, now what about if I'm approaching 2? Well, let's go ahead and look at this. So we already did the right side. So let's put a little question mark over our equal sign here. And on the right side, we already know it was -1/2 times 2 minus 1, which of course was -2. On the left side, we're going to use the other function, which was, see if I can get both of these things in the screen, which is this one here, right? That would be when it is smaller than 2. We'd need to use this one, right? Because x is less than 2. So we're going to use that one. And so I'm going to go ahead and say x plus 2. Sorry, did that wrong. 2 plus 1, my bad. I'm plugging in 2 for x. Squared minus 6. 2 plus 1 is 3. 3 squared is 9. 9 minus 6 is 3. Does 3 equal -2? No, which obviously from up here we know this limit isn't going to exist. But now we've proven it. And why? Because the left side didn't equal the right side. Okay, so we proved it. Next one. I'm going to do -3 from the left. So let's scroll up and see where that is. I want -3. That's the first two functions from the left, meaning it's bigger or smaller than -3. If it's from the left. A little bit smaller. So that means I need this first one. So -x minus 5. So this is going to be -3 minus 5. No, minus -5. Minus -5, sorry. Minus -5. Because it was originally -5, so it's minus -5. Equals 2. Oh, that's the way it was. I knew there was a double negative there somewhere. Thank you. This is what happens when I'm not trying to scroll up and down. You guys can look at it all at once. I can only look at a little piece. So I'm trying to do it from memory. Yeah, sorry, it was -x, so -3. I knew there was a double negative in there. There we go. So we get -2. And of course, if you look at the graph up here, there we go. From the left, we can see that's correct. Now let's do it from the right, which means I need to use this one, right? Because this is where x is a little bit bigger than -3. So I'm going to use the function that was x plus 1? Minus 1? What was the function again? Plus 1 squared minus 6. There we go. Thank you. All right, negative 3 plus 1 is negative 2. Negative 2 squared is 4. Minus 6 is negative 2. Excellent.
Hey, how did you get these equations?
You missed that, buddy. I'm not going to make everyone listen to it again. All right, so now this one here, we're going to look at negative 7. If I'm at negative 7, which of these three graphs should I be using? I heard two different answers. I heard the bottom and the top. Why the bottom one? Negative 7 is greater than 2? The top one, because negative 7 is less than negative 3. So we're going to use the top one. So we get negative 7 minus 5, which equals 2. And then we should compare that. So let's go look here at negative 7. Hey, look. It's right there at 2. Amazing. Okay, our last one, approaching negative 1. If we're approaching negative 1, which of these three graphs are we in? The middle one. And so I get negative 1 plus 1 squared minus 6. This is 0. 0 squared is 0, so it's just minus 6. Let's go confirm that. At minus 1, right here, at negative 6. Perfect, we did it right. Any questions about those?
Did you get the equations?
I already talked about how to get the equations. You got to listen.
Yes, sir. Can you explain me how did you got the three equations of the top? I don't know.
I already explained those equations. Who can help these two out? I already went over the equations. How did I do it?
No, sir. If I had it last first, you would have stayed.
The first one and the last one is just a line. So I'm literally just finding y equals mx plus b. So the slope, which this one is negative 1, and then if I extend the line, it's going to hit it down here at negative 5. This one here, my slope is negative 1/2. If I extend it, it's going to hit the y-axis at negative 1. So that's those two. The middle one, you guys didn't remember very well, but this is what we call vertex form. So I write it in the form of x minus the x-coordinate of the vertex squared. So x minus negative 1, or x plus 1 squared. And then on the outside, I put the y-coordinate, so minus 6. If you don't remember how to do
You
this,
always square it.
yeah, it's always how we write a vertex form of a quadratic. All right,
Yeah, look at my that for them.
let's do the next one, piecewise function. All right, consider the function. We're going to find each limit. If it doesn't exist, state y. We already know y. Left side doesn't equal right side. Okay. The limit as x approaches negative 2 from the left. Which of the three equations should I be using?
The first one.
The first one, why?
You're approaching from the left.
From the left, which means x would be smaller than negative 2. Exactly. So I'm going to use that first one, and I'm just going to try and plug it in, right? So 2, negative 2 squared, plus 3 times negative 2, which is going to be negative 2 squared is 4, 8, minus 6. So my answer is just 2. You all with me on that? Yeah, we're good? Excellent. All right, then the limit as x approaches negative 2 from the right. Use the bottom one because now x is bigger than negative 2. Exactly. So negative 1/2 times negative 2 plus 1. Negative 1/2 times negative 2 is positive 1. Plus 1 equals 2. If the left side equaled the right side, what is the limit as x approaches negative 2 from both sides? Exactly, right? Our left side equaled the right side as we just proved. So we're done. Amazing. Oh. All right. Let's try some analytic approaches to these limits, all right? First thing I always do, plug it in. What's the ln of e, or the natural logarithm of e? 1, exactly. So this is literally just going to be 1 over 2e.
Oh, no, I can't please, sorry.
Guys, I'm just plugging it in. So ln of e over 2e. So the 2e makes sense. Ln of e, the natural logarithm of e. Natural logarithm is literally logarithm base e. So we're asking, like, e to the power of what equals e? 1. So the ln of e is 1. You should memorize that one. You're going to use it a lot. Okay? All right, next up, this one, same thing. We're just going to try plugging it in, see what we get. 2/5 times 5 squared plus 2 times 5. And I get, what is that, 25? Over 5 is 5, so 10 plus 10, or 20. I know I'm going through algebra quick, but that's because you guys are experts at algebra by the time you're in calculus. All right? Next up, now we're going to approach pi. So I'm just going to plug pi in everywhere. So I'm going to get sine squared of pi plus 2 cosine of pi. What's sine of pi? We already did it today. 0. 0 squared is still 0. I mean, just doesn't matter. What's cosine of pi? Close? -1, because it's on the other side of the unit circle. So in final, my answer is -2. Making sense? Feeling smart? Yeah, some of us are. Good work. All right. So now I've got alpha instead of theta. It doesn't matter. It's just a variable, right? And once again, I'm going to plug this in. So this is going to be tangent of 5 pi over 3 over 5 pi over 3 squared. So first things first, tangent of 5 pi over 3. So that's the same as being sine of 5 pi over 3 over cosine of 5 pi over 3.
It's negative square root of 3.
Yep, exactly. We're in quadrant 4. And if you go and look them up, guys, you'll see it. Okay? But this is going to be -√3 over 25 pi squared over 9. How do I get rid of fraction of fractions? Keep, change, flip. That goes away now, right? So I get -9√3 over 25 pi squared. I mean, it's ugly, but it's a number. All right, last one. Oh, I'll wait. Are you at least with me on D there? No, we got lost on D. What's wrong? Which part? Which part?
Where do you get the scribble?
The scribble?
Yeah, explain everything from the part. Yes.
Okay, I think probably the only part that you're actually having trouble with is this, so let's pull that out. That's the same as sine of 5 pi over 3 over cosine of 5 pi over 3. The sine of 5 pi over 3, if you use its unit circle, is going to be √3 over 2, negative, because it's in quadrant 4. Cosine of that same thing is going to be +1/2. To divide the fractions, I keep, change, flip. And what happens to those 2's? They cancel, and I don't need to bother writing that this is over 1. So that's where I got my -√3. This part, I'm literally just squaring 5 pi over 3. And then I get same thing, keep, change, flip. Okay? 25 pi squared over 9, which becomes multiplied by 9 over 25 pi squared. Because we keep the first one, change division to multiplication, flip the second. All right. What happens when I plug in -2 to this last one? I'm going to get a 0 on the bottom. We can't do that. So I'm going to need to factor this thing. So I'm going to still take the limit. As x approaches -2, the top's going to become x minus 3, x plus 2. The bottom, it just has a common factor, so I'm going to pull out a 2 and get x plus 2. That's fantastic, because my problem just disappeared. It canceled. It means it's a point of discontinuity, which means the limit could still exist. So let's work out the limit then. So now I just plug it in. -2 minus 3 over 2, which is -5/2. Feeling good and smart? I really enjoy the glare. Does that one make sense though, guys? For real? You're okay? Right? If you get a problem on the bottom, the first thing you should try is factoring, same as you did in pre-calc. It's just that now we're doing the limit, which means if it doesn't exist, we can still take the limit. Okay? Next one, what's going to happen here? So we're going to end up dividing by 0. Guys, what's the problem this time? Can I factor that in a way that's helpful? I can't factor that in a way that's helpful because we know the bottom is x minus 3, x plus 3. So the only thing I can do is an analysis. At this point, I know that it's an asymptote. So it's going where? What are the only two options? Positive infinity or negative infinity. All I got to do is figure out which one, right? So let's still write this as our factored form because it's a little bit easier to do the work. So what I want to do is plug it in 3. We're going to go left and right. So the left side, and then we're going to do the right side, right? See if they go to the same thing. On the left side, so that means I need something a little bit smaller. Let's try, say, 2.9. Okay? The top, 2.9 plus 5 is positive. The bottom, 2.9 plus 3 is positive. 2.9 minus 3 is negative. What is a positive divided by a positive times a negative? Negative overall. So this one's going to negative infinity. Because remember, we know that it's an asymptote. It only has two options, positive or negative infinity. So we do a sign analysis like we did earlier to figure out which one it is. So now from the right side, I'm going to use 3.1. And I guess you could do this to show like you're estimating. 3.1 plus 5, positive. 3.1 plus 3, positive. 3.1 minus 3, positive. Positive divided by positive times positive. It's all positive. It's all right, positive infinity. So what does this mean about this whole limit? Exactly, it doesn't exist, right? Doesn't exist because the left side does not equal the right side as per what we just did there. We showed that they went in opposite directions. Amazing. All right. Oh, the next one's kind of gross. See how well you guys remember how to do this. Okay. Matthias, if I plug in 0, what happens to the bottom? Right here. No, it becomes 0. 3 halves times 2 is 3. 3 minus 3 is, uh-oh. There's our problem. Oh, sorry. I meant, what happens if I plug in 3 halves? You're right then, Matthias. Sorry about that. Yeah. Okay. So either way, the point is this is 0. So I need to go ahead and factor it. Who remembers how to factor the top? So you could do remainder theorem. You could do all these things. Realistically, if I'm giving you this question, what is this going to be, most likely? A factor of the top. If it isn't a factor, then what's my answer? It's an asymptote. Check for positive or negative infinity. I don't need to actually factor the top. I just need to know if 2x minus 3 is a factor. So do you guys want to do synthetic division or long division? Synthetic division or long division? I heard a couple of both, and I heard a couple of K. All right, we'll do it long way. We'll do it the long way. We'll do it the long way to see if you remember. No, you're not. Plus 0x squared plus 0x minus 27. We can maybe do synthetic after if you want. Okay. Because I have to. In order to figure out whether I'm doing synthetic or long division, I have to add in placeholders for the other degrees of x. Manuel, if you can't keep quiet, man, you should leave. Okay? All right. Amalia, what do I do next? No, that's not true. How many times does 2x go into 8x cubed?
3.
4. 4x squared. Right? 4x squared times 2x would give me 8x cubed. Agreed? Okay? So then I multiply. 4x squared times 2x minus 3 is 8x cubed minus 12x squared. Then I subtract. This is 0. Because what's 4x squared times negative 3? Negative 12. Then I'm subtracting, so this becomes positive 12x squared. Then I'll bring down the next term. 2x goes into 12x squared. 6x times. I just realized I wrote these, sorry. These should be over a little bit, right? You should line them up. 4x squared plus 6x, my bad. All right, 6x times 2x is 12x squared. 6x times negative 3 is minus 18x. Subtract. I'm going to get 0 and 18x. Bring down the next one. Guys, it's not that confusing. You've done it before. No, I promise you, you have. I didn't. Your pre-calc teacher did. Okay, so you didn't do it, but everyone else did. That's okay, it's okay. It's okay, guys. We're still remembering. We're going through it. It's all right. So now, 2x goes into 18x 9 times. So that gives me 18x. 9 times negative 3 is negative 27. When I subtract, it gets 0. Perfect. That means it's a factor. So, now I can rewrite it as being 2x minus 3 times 4x squared plus 6x plus 9 all over 2x minus 3. And what happens to that thing that's annoying? It goes away. If it didn't, it's going to infinity or negative infinity. Tell me which one by analysis. Okay? Now we're just going to plug that in. So we're going to get 4 times 3 halves squared plus 6 times 3 halves plus 9. 3 halves squared is 9 over 4, which is going to be 9 when we multiply by 4. 6 times 3 halves is going to be 9 plus 9. Oh, that was a lot of work to tell me I went to 27. Guys, once we learn how to take the derivative, we're going to use something called L'Hopital's rule, and this question is going to be so easy, you're going to do it in about 5 seconds. But until you learn L'Hopital's rule, you can't do it. You got to do it this way. Yeah, Pablo.
Why after doing the division, you again put up and down that 2x minus 3?
Because, so I did the long division to factor the numerator. So this up here is my numerator, and on the bottom, my denominator hasn't changed. It's still 2x minus 3. Right? All I'm doing is rewriting, I'm literally rewriting this like that, as that new fraction, or new rational expression. Okay? I factored the top, it's a lot harder to factor a trinomial. That's all it is. Awesome. All right, next one. I told you guys this was a big lesson. All right, next one here. If you see the square root here and there's a problem at the bottom, what should you probably do?
Multiply by square root.
Kind of.
Yeah, like by the top.
The conjugate is what we called it. Yeah, 2x plus 5 plus 1. Square root of 2x plus 5 plus 1. The whole reason we're doing this is we made a difference of squares on the top, which means that, yeah, so the top is literally going to become that. The bottom, I'm going to leave it in factored form because the whole point of doing this is that I'm hoping this cancels. And if it doesn't, it goes to infinity. And so I just check which positive or negative infinity, right? That's why I can kind of cheat. I can just say, well, I'm going to leave it as factored because if the top doesn't factor out the x plus 2, it's an asymptote. Okay? So if I simplify that top, it's going to be 2x plus 4 over the same thing. I'm not going to write it out just yet because we got one more step here. I can factor the top to be 2 times x plus 2, correct? The bottom is x plus 2 and our square root of like 2x plus 5 plus 1. Because I got rid of my x plus 2. Do you agree?
Yes.
If it didn't work, what do we know is happening? Where is it going? There's only 2 possibilities. Infinity or negative infinity. Thankfully, it did go away. This is still the limit, sorry. All right, so let's take this over here now and actually do it. So the limit as x approaches negative 2 of 2 over the square root of 2x plus 5 plus 1. What do? I just plug it in, right? 2 over the square root of 2 times negative 2 plus 5 plus 1. It's a little hard to read that, sorry. So this is 2 over the square root of 1, which is 1, plus 1 is 2. What does this thing go into? Just 1. Okay? I know it's a bunch of work to do these. The algebra is the hard part. I didn't mean to scroll. I didn't mean to scroll. That was an accident. It was an accident. I didn't mean to scroll it. Oh, I don't know if we're going to get them done. I think we still have like 4 left, if I remember right. There's only one more page. Guys, those are the practice. The practice you do on your own.
These are practice.
Right. I'll explain after. Can I keep going now?
Wait, no.
It's not homework.
No, mister.
Can I keep going or no?
One more.
Guys, we're not stopping there. At the very least, we need to finish this page. At the very, very least, we need to finish this page.
Okay.
Manuel, you should go take a walk, buddy.
We have to be quiet here.
I don't think you guys realize how little time we have. Because I only see you 3 times a week. That's the problem. Okay, here.
We should make an arrangement to see each other like 4 or 5 times.
Yeah. Guys, what would I do on this one? If it's a square root again, what should I do? Do that same conjugate thing, right? Okay? I want you to try that one on your own later. Because I already showed you how to do it. And at the beginning of class, next class, we'll see if you did it. We're going to jump down. Because I want to make sure that we do one like this, which is a different style. Do you know what I mean by it? Okay, here, let's at least write out the first part. This would be 1 plus the square root of 2x squared minus 1 over 1 plus the square root of 2x squared minus 1, right? Just the conjugate, same as we did in the last question. Right, and then I'm going to simplify the top. I'm going to leave the bottom as it is. I'm going to hope that that x minus 1 goes away. It does. You're going to find out what the limit is for me. Okay? Yeah? All right, guys, so just to finish this one up, we let you try it on your own. So, of course, this was here where we just simplified after multiplying by the conjugate. Then here I'm just simplifying the numerator. I'm not going to rewrite that denominator every time because it's annoying to write. And I'm going to draw a line to show that I'm still taking the limit. Then once I've simplified the top here, you can see that I'm able to get it into a difference of squares. So then I factored that, which does allow me to cancel out that problematic x minus 1. So then I rewrote it, and then I plugged in my positive 1 for x, and I was able to get the answer of negative 2. All right, let's try the next couple. Finish off this lesson here. So for this one here, the very first thing I'm going to need to do is simplify that top. Simplify that numerator, see if anything goes away, because obviously right now I'm dividing by 0. That means I'm going to need to multiply this fraction over here by x over x, and this one by x over 2, because that's how I'm going to get a common denominator. So that means that I'm going to take the limit of x over xx plus 2 plus x plus 2, because I'm multiplying these in, over xx plus 2, which of course then I can put those together. That's going to give me, sorry, and the whole thing is still over x. That's going to, now I can combine the numerator, get 2x plus 2. over x plus 2. Then I can keep change flip to multiply by another 1 over x. And unfortunately, nothing is going to go away here. I can't get rid of these x's on the bottom, so I am going to be dividing by 0. That tells me that what I'm going to be doing is hitting an asymptote. And once I'm hitting an asymptote, that's where now what I wanted to check is it going to positive or negative infinity? So we're going to use the left side and right side method. For the left side, we're going to use negative 0.1. For the right side, we're going to use 0.1. And we're just going to plug it in into that form there. So into this form here. And so let's see, I'm going to get negative 0.1 times 2 plus 2, that's going to be a positive, over a negative times a negative is a positive, times another positive, so it's positive, negative, negative, which means I'm going to have a positive divided by a negative times negative, which is a positive overall. So this whole thing just goes to positive, which means it's positive infinity on the right. On the left, sorry. On the right side, I'm going to do 0.1. This one's even easier to see that all of these are positive. So it's going to positive infinity. And so, therefore, the limit as x approaches 0 of, let's call that function up there, f of x, is going to simply be infinity. Because both the left side and right side went to positive infinity. All right. Next one here, we plug in 2. We're going to see that we've got a problem. We're going to get 0, so we're going to try factoring it before we do anything else. I'm going to factor something that adds to 7, multiplies to 6, which is 6 and 1. So I'm going to get 3x plus 1 times x plus 2. If you can't figure out how to do that factoring quickly in your head, go ahead and just take time, pause it, and do it. And then this one's going to be x plus 2 and x minus 2. Those are going to cancel. And so this is still my limit. So I'm going to be left with a limit as x approaches 2 from the right of 3x plus 1 over x minus 2. When I do that, I'm still going to be approaching 0 here on the bottom. So we know that it's going to be going to infinity. I don't need to check the left side. I only need to check the right side here. And so we're going to say plug in 2.1. I'm going to get infinity or positive over positive, which of course means that my answer is going to be positive infinity. All right, last two here. We're going to approach 3. There's nothing I can do here from the right. It's going to end up going to an asymptote, which means that I'm just going to go ahead and do my right-hand side check. I'm going to check 3.1 because that's a little bigger than 3. 2 times 3.1 plus 6 or plus 5 is still going to be positive. 3.1 minus 3 is still positive. So this one is going to positive infinity. On this side, it's exactly the same. I can't simplify it. This time we're going to check the left side though. So I'm going to check 2.9. 2.9 times 2 plus 5 is positive. 2.9 minus 3 though is negative. So this one is going to negative infinity instead. So this means that if I were to put all of this together here and just do the limit as x approaches 3 of 2x plus 5 over x minus 3, the answer would be does not exist, because the left and right side are approaching different infinities. All right, guys, that's going to be it. I know that's a long one. Apologies. The rest of this is your practice problems.